Prepare a compass, a protractor, 2 rulers, if possible 1 long ruler and 1 short ruler. Now crank means the CO, which rotating in clockwise direction. It's 80 revolutions per minute. Later we need convert into radian per second. Clockwise direction. Now it's slider. Slider means P here. And also velocity of P is velocity of PO, which represent velocity of P relative to O, the origin. Next is angular velocity, the omega of connecting of rod, which is the PC. Later we can find omega PC from tangential velocity of PC. Next is velocity at Q, which is VQO, relative to origin O. First, you must draw a space diagram. The questions given may not according to scale, so you must draw your own set. Take an appropriate scale. You can see that you have link dimension of 32 centimeters, 8 centimeters, so the appropriate one will be 1 centimeter to 4 centimeters ratio, where in space diagram 1 centimeter represent 4 centimeters in the real dimension. Draw a straight line first, if can draw on the lines in the foolscap paper to ensure a straight line. Use your protractor to draw the angle now, it's 45° horizontal to the baseline. Next label your O. CO is 8 centimeters in reality, so in space diagram, the scale is 1 centimeter to 4 centimeters, meaning the dimension will be 2 centimeters according to the scale in your space diagram. Measure 2 centimeters from O. Then label your C. 8 centimeters in space diagram. Prepare your compass. Stretch and measure on your ruler for 8 centimeters. Put the sharp tip on point C and sketch on the other end of horizontal line. Now joint the line. Put all your details, your scale, the real dimension, all. Make sure all the points are in your space diagram. Remember your point P. We can know all these after drawing velocity diagram. Let's evaluate the tangential velocity, clockwise therefore. Link CO rotating about the point O with clockwise direction, so that's why the tangential velocity will be pointing upwards like this, always perpendicular to CO as well. Put a ruler on the link CO now. Next put another ruler 90 degree to it. Draw the line, which is the tangential velocity of CO, the VCO. This also means the velocity of point C relative to O. Make sure it's perpendicular to link CO. Next it's drawing the line of velocity link PC. The direction is unknown since their angular velocity is not given. Do not assume the direction yourself. It's just a line perpendicular to PC. Again put your ruler on link PC, another ruler perpendicular on it and draw the line through P. Remember, do not put the direction, it's just a straight line through P, because we do not know the direction. So this is tangential velocity of PC, VPC. Velocity of point P relative to C. Last is the slider, which can only moves left or right. Again, no direction should be assumed, but just a straight horizontal line through the slider point P. To convert into radian per second. RCO is radius of CO. Link CO is rotating about the point O, so the radius is simply link CO. Remember to convert it into meter. Set a new scale for your velocity diagram, according to your calculated tangential velocity. Put a ruler on the link CO. Transfer the tangential velocity VCO to velocity diagram. Make sure it's totally parallel. Measure 6.7 centimeters according to scale you set earlier. Now for drawing purposes only, you define your VCO, where this is pointing to C, from O. Small sketch, arrow is in your space diagram. It should be pointing to C, so arrow is directed to C. And from O. Copy your small sketch to the velocity diagram. Label the direction, the point C and point O. In velocity diagram, there should be points and direction only. In velocity diagram, there is only C, no P, the only reference is from C. Put a ruler on link PC, another ruler perpendicular to it. Transfer VPC down, through C. Again, do not put direction first, but I know it must be from C, either up or down. You only see O, so through O. You know it's a horizontal straight line. You can measure it to O, then measure it again to achieve a perfect straight line. Both lines you drawn intersect, which is P. Label everything. This is VPC. Remember that VPC is pointing to P. From C, you have your diagram with points P and C. So the arrow should be pointing to P. This is VPO, pointing to P. Measure the dimension in your velocity diagram. After you convert into your scale, it will be the velocity. To find the angular velocity, simply use the formula and put in the values you obtained earlier and the given dimension. Remember to convert everything into meter. Refer to the real dimension. Last is the velocity of Q, VQO. Just use the ratio. PC is 32 centimeters in reality. Notice that Q is near to C, so draw Q near to C. Measure earlier that PC is 4.6 centimeters. By ratio, the length of CQ should be 1.15 centimeters. Draw 1.15 centimeters in your velocity diagram. Remember, different people will draw different velocity diagram, so calculate your own ratio. Now draw this Q relative to O. Measure it and with scale. That's your velocity of VCO.